This is a reaction where propane, like the propane in most grills, is being reacted with 5 molecules of oxygen to give 3 molecules of carbon dioxide and 4 molecules of water. So now I know how to interpret chemical equations. I want to be able to glean useful information from these chemical equations. For instance, if I'm told that I have 100 grams of propane and it's burned with oxygen as much as it is required to get rid of this 100 grams, how much carbon dioxide and how much water would be produced? What I'm going to be doing is using this chemical equation to figure out how much of each of the products comes from 100 grams of propane. And I'm going to do that by the fact that 1 molecule of propane gives 3 molecules of carbon dioxide and 4 molecules of water, assuming that there is as much oxygen as I need. And in a normal atmosphere, at least on this planet, there is as much oxygen as I need. Hopefully it doesn't run out when I'm trying to do this reaction, obviously. So what I can do is convert this to moles by using the molar mass. And now I have this in moles. And instead of thinking this reaction as a reaction of individual molecules, I can think of it on a grander scale. 1 mole of propane reacts with 5 moles of oxygen to give 3 moles of carbon dioxide and 4 moles of water. So when I convert this mass into moles, and assuming, for instance, if it was 2 moles, that means I would get 6 moles of carbon dioxide and 8 moles of oxygen or of water. And once I know how many moles of each of these products I have, then I can convert them back into mass by using their individual molar masses. So that is the plan to solve a problem like this. I'm going to begin by finding out the molar mass of the known quantity. So carbon, 12.01 grams per mole times 3, which is equal to 36.01. And then hydrogen, times 8. I total these up, and this gives me 44.09, or point. Oh no, this is 03. That was my mistake. 44.11 grams per mole. And that is the molar mass of propane, C3H8. Now that I have the molar mass, I can find out how many moles 100 grams of propane is. So I have 100 grams. And there are 44.11 grams in 1 mole. And I did all this calculation out beforehand, and this gives 2.27 moles of propane. Now that I know the moles of propane, and I'm looking for the grams of CO2 and the grams of water. But now that I know the moles, I can figure out how many moles of carbon dioxide in water, because I know for every 1 mole of propane, I have 3 moles of carbon dioxide and 4 moles of water. So I can figure out each one of them individually. I'll do carbon dioxide first. So if I have 2.27 moles of propane, for every 1 mole of propane, I get 3 moles of carbon dioxide. So it's pretty simple. I just multiply 2.27 by 3. And then after that, I'll convert it back to grams. And this gives 6.81 moles CO2. So now that I have the moles of CO2, I can figure out CO2's molar mass. It's 12.01, oxygen is 15.99, and there are 2 of them. 12.01, 15.99 times 2 is 31.98. Tally these up, and this gives 43.99. And this is the molar mass of CO2. Now I can use this to figure out the grams of CO2. I have 6.81 moles of CO2, and in 1 mole has a mass of 43.99 grams. Now I do this multiplication, and this gives me 299.57 grams of CO2. So this is one of the answers. Now I need to figure out how much water there is in grams. So let me go back up here. I had 2.27 moles of C3H8, and for every mole of propane I have 4 moles of water. 2.27 moles of propane for every 1 mole of propane I get 4 moles of water, which will mean that I have a total of 9.808 moles of H2O. The molar mass of is equal to 18.01. Seen that a bunch of times. Now I just use this conversion. 9.08 moles H2O. 1 mole is 18.01 grams, which would give 163.5 grams. 53. Oh. That's right, what it was. So the total answer, I guess I'll write that down here, is 299.57 grams. And 3.53